Okay, Damit, you want to start?
Sure. So, welcome everyone to Cloud Native Computing Group Ahmedabad. We are based out of western part of India for people who are not from India in this call, especially Gorkem.
Hmm.
And we are doing this CNCF project tours. It was an idea that Shivlal had once upon a time while, I don't know, he was having some kind of thoughts what to do next, how to have some interesting talks. And he came up with this virtual talks, and so far we have had some interesting sessions from Falco, Kyverno, etc. And today we are having folks from KitOps. That's a tool from people at Jozu, and we are going to have two speakers, Shivay and Gorkam. They're going to talk to us about KitOps, and yeah, it's going to be more of a conversational session today. It's something we learned from Falco session last time. Keeping it conversational was really interesting, and there was a lot more fun that folks had. Um, and from the hosting side, it's Shivlal, Sandeep, and me. We are going to try and moderate the sessions. But before we get started, Shiva and Gorkam, I was taking a look at KitOps sometime before this meetup, and my very short takeaway is that KitOps seems like Helm, but for LLMs. Now, I could be absolutely wrong here. So, with that, let's get started. Let's learn what KitOps is about.
Yeah. Well, Darmid and I actually worked in tooling space in the same company at Red Hat before. So, like one of the things I always say that is like a good tool is one that the users of the tool come up with ways that you don't expect. Uh, it you don't like the original intention of the tool may not be that, but then the people will start using it different ways and come up with different ways of working with the tool. I mean, for instance, we really didn't intend the kit CLI and KitOps to be Helm, but on the other hand, it kind of grew to that direction as well. It wasn't originally as Helm, but you can think of it as a little bit like Helm as well. We do not uh, directly manage deployments on KitOps, but we do manage the LLMs and other models as well. We're very model agnostic, so it doesn't need to be LLMs. We do manage all AI ML artifacts essentially. So let me just give a quick introduction to KitOps. Maybe let's start with that. And for those, I am going to try something new. Let's see what happens. I'm going to share my website, the KitOps website. It's a wonderful website. So we'll do a quick tour of the website, and also I'll do a little introduction of what KitOps is. So the reason why we created KitOps was we thought that uh, a, a seemingly basic problem like how to store your AI ML artifacts in a manner that is secure and also compatible with many different scenarios and many different fairly complicated pipelines was another solved problem. If you look at what exists out there today or a year ago when we started, is you have multiple ways of storing models and data sets and associating them with each other. I mean, you have uh, models that are trained by data sets, and the only relationship between them is a line in an Excel sheet. I mean, I have encountered that. So we thought that this needs to be more secure, more simple. The relationships should not be an afterthought, but like built into the storage and the built into the distribution. So and we wanted this to be as compatible with what exists today as possible. So the idea was to create an OCI artifact that would actually store all the elements of an AI project. So the obvious one is your model weights, but then you can think of your data sets, your code, your documentation, your configuration, obviously, is all those things that you can store in this artifact. So let's go to the docs at this point and see what is inside a model kit, right? So a model kit is essentially, as I said, is a OCI artifact, and if you go to the website and if you like reading specifications, we do have a specification of what that artifact model kit OCI artifact looks like. I think this is very important because for someone who wants to have a tool that works with the specification, they can just look into the specification and implement the same OCI artifact with the same media types and be just interoperable with the existing model kit tooling. And what is inside the model kit, as I said, is like there is a kit file which we basically store what to package in. Essentially, it's very similar to a Docker file, but it's different than Docker file in the sense that we only have a definition of what needs to be stored, whereas Docker files have commands that you can run. It's like it can do copies and it can do run things. Kit file does not have that sort of commands, but it only has a declaration of what needs to be stored, which then can include any of these 5 things or 4 things, 5 things essentially that you see in there. You can have a model, you can have code, you can have data sets, and you can have documentation. And you can have neither of them as well. So you can create a model kit that is completely empty as well, but like that serves no purpose, but technically it is possible. But you can have, a model kit that only has a data set. And we do have a lot of users that does that. Or you can have a model that only has models, which is very common. And then you can add parameters to it. The good thing about OCI is because it's by default immutable. So once you created a model kit, you cannot change it. Once you push it, it's content addressable storage, and you can only access it through a SHA, essentially. And therefore, once you created the model kit, the only way to create or change it is to actually create a second version of it. So why is that important? This is important because let's say that you trained a model and you have a data set that goes with it, and you want to find out what data set you have used for training that model. So that content addressable storage gives you a very precise information saying that, oh, this was the model that was used for it. This was the data set that was used for training this model. So there is no guessing. There is no Excel sheets that someone can just go in and modify, right? So it kind of adds a level of security and you basically didn't have to do anything for it. We talked a little bit about the kit file. So again, the website has a lot of information on what a kit file looks like and can store, but here is a small example of it. As I said, it's not a complicated file in the sense that, it's YAML, all right, and we are CNCF, so we kind of like YAML, don't we? So and then it gives you there's a package section which gives you a little bit of general information like the licenses and descriptions and so on and so forth, stuff that the tools would typically show on a UI or something. And then you can define each of your layers. So the code layer is, you can have multiple code layers, you can have a single model layer, and then it's not visible here, but you can also have what we call model parts, so that you can have multiple models essentially, but then there's always one leading model in there. And we can talk about the reasons for that as well. And then you can have multiple data set layers and multiple documentation layers, although this example doesn't have a documentation layer. The only thing that is actually mandatory here is this, the manifest version. Other than that, everything is technically optional, but we do think that you need to have at least manifest version and one of the layers, code, model, dataset, or document layers. But other than that, everything else is optional. So you can have, it's a very flexible configuration. The thing that, and this is the minimal, essentially, there's an example for it. The thing that the Kit CLI does is when you are trying to package this, and let's go to the Kit CLI, and these are all the commands that you can have with the Kit CLI, is the thing that it does is it goes and reads the Kit file and resolves all the files that the Kit file references with respect to the Kit file location. So if you have relative, well, you can't use obsolete paths. You need to use relative paths, and those relative paths needs to be relative to the Kit file itself. And then packages them into the OCI artifact that I have just showed you with the ModelKit specification. And the kit pack command does this. It's very similar to, I suppose, Docker build. But then you can also, once you're done with it, you can also push it to a Docker registry. So yes, I said Docker registry because it's an OCI artifact. So any registry in OCI registry that it's compatible with OCI artifacts, which is pretty much all of them nowadays, you can essentially put that into that registry. So there are advantages to this as well, because now your registry where you store your AI and ML artifacts is actually inheriting the same things that your Docker containers always had. Like, for instance, for an enterprise, you can think of it as, oh, how do I authenticate and authorize users to have access to models, right? That's a problem if you are coming up with a new system. But that's not a problem if you already have a registry that you solved this problem for. If you need auditing, you can enable that on any OCI registry you probably have, as if you're an enterprise, and so on and so forth. Another advantage of the OCI is you can use the existing ecosystem, and we'll come to that as well. But let's go and look at a few of the major commands here on the Kit CLI. One of the things is, like we talked about, the pack and push. You can also do a pull, which is very similar to Docker pull. What it will do is it will pull the model kit into the local cache, which you can then use from there, which is the pack command, the unpack command, sorry. And when you do a kit unpack, what it will do is it will look into your local cache, and if it can find the what you're trying to unpack in the local cache, it will use it from there. If not, it will go to the remote and skip the cache, but still do the unpack. So there is a big difference between kit unpack and kit pull, which is kit pull always pulls to the local cache, and kit unpack uses from local cache. If it cannot find it from local cache, it will use it from the remote cache. And there's a reason for that. The reason is when you are using in a production environment, like a deployment scenario, and you just want to unpack your model, you do not want to unpack to a local cache and then unpack it again. Like that would require you to copy a very large file and then copy it again on the drive on your, even though in a SSD drive, like it takes time because these things, especially with the models and the data sets, can tend to get really, really large. So to avoid that, kit unpack only just downloads and unpacks and never copies to the disk and then unpacks from the disk. So there's that difference that we have introduced. Where was I? Oh, yeah. And I said, if you want to just unpack a model, there is a flag in kit unpack, which we call the filter. And you can tell, I don't know if you can see it very well in there. For instance, if you want to unpack only certain parts of a model kit, let's say that you want only the models and data sets, then you can just say on the filter that, hey, I want just the model and the data set. Or you can even do a bit more fancy and say, I want a data set, but I want the data set that is named or the path is my data set, right? Or if you want to just unpack the README, you can do that as well. And you can say that, oh, just unpack me the readme.md and that's all I want to see. So there is a very useful filtering mechanism on the unpack where you can actually choose what you want to unpack depending on your situation. Remember, our first goal, one of the first goals with KitOps was, we want to be able to use this in different pipelines, different situations. So whether you're doing an evaluation pipeline or a training pipeline or a deployment pipeline, right? Or it may even be that you're just creating a documentation site for your model kits. You should be able to use KitOps to do that. And then there are other commands that may be interesting here as well. I'll just go over them a little bit. We have a diff command which allows you to see if the differences between two model kits. This is for the situations where, it's like I trained this one and then someone else sent me another model kit. What's the difference between them? Is it a new license? Is it a new data set? And so on, so forth. We have an import command that allows you to import model kits directly from Hugging Face, essentially. The info command is going to basically read you the information that you see on the kit file. Init command is for creating a kit file easily. So it will basically scan the contents of a folder and then suggest the kit file by looking at the contents. So it's something that may become useful. And kit inspect is basically the OCI manifest. That's how you read it. Kit list lists you your locally available model kits, but also it has a way to list the remote ones as well. So you can specify the remote tag as well, and then it will give you those. Login and logout are obvious. It's for logging and logging out of OCR registries. We talked about pack, pull, push. Remove is if you want to remove a repository, a model kit from your local cache or from remote as well. There is a remote flag. Tag is for tagging an existing model kit, and the version gives you the version information. And one command that we skipped is the dev command. So dev command does something that is a little bit sort of an experimental for us. Is it actually can run an LLM locally. So it's kind of similar functionality to Olama, but we are not like KitOps' main purpose is not to provide a local runtime for your LLMs, but we thought that it would be handy if you are using an LLM. It would be handy to have a development environment that you can run with ModelKits. So it's basically looks into your kit file and from there it runs the model if it can run the model, and then you can see you can start it, stop it, and see the logs. So that's the related commands. And then we have cache management as well as part of the kit command. And in addition to the kit CLI, we also have a Python library. So if you are doing your training evaluation pipelines in Python, you can use the Python bindings. This is essentially gives you the same kind of usage as the kit CLI. It actually does use the kit CLI underneath. But then there are a few things that you can do more flexibility in the Python API. And we talk a little bit about integrations with MLflow and other CI/CD tools. We have a Docker module that you can use for CI/CD, and also a GitHub action for making the kit CLI available on a GitHub action. And that was the short introduction. And all this information is in this wonderful website. So you can go here and read all about it. And if you forget about it, we can come back here, kitops.org.
Yep. So I have one question.
I think yeah, good, sir.
Yeah. So sorry to interrupt, Shivay. So I have a question that you mentioned about the registries here. So are this like model kits we are going to upload to registries, and KitOps will help us to directly pull the model kits, and it will run the that as a model in your local, as you mentioned about the KitOps, kit dev start. So will this work the same?
You mean like for model kits? For any model kit?
Yeah.
It works the same. It's basically you can create a model kit with a model in it, push that to any Docker registry. We've been testing it with many registries. So, and then once you do a pull or unpack, you can just say to the dev command to start with the location of the kit file, and then it will just run it. The only caveat in there is right now we only support GGUF models that are packaged as GGUF, which is similar to what everyone else does. Like if you look at projects like Olama, Ramalama, what's the Docker one? I can't remember the name. But all of them basically do the same as well. So everyone runs GGUF for some reason locally. Yeah.
Yep, that answers my question.
Yeah, I think I was just saying this, Shivlal, before you had asked that question, that ultimately the way that I like to always talk about KitOps is that, as you saw with all of the different commands that are present right now, that honestly, like the way that it has been designed is to give the same level of user experience that, or developer experience that you might have if you're already working or you're working a lot with Docker. So you'll see like a lot of the commands follow a similar structure. And the great thing about being able to then package your models into a format that is supported by OCI is the idea that now you can use it with the same set of DevOps tools that you would typically use. So whether it's integrations with different kinds of CI/CD tooling, such as whether it's GitHub Actions or it's Dagger, or even something like there are a couple of ones that come to my mind that we all like there are already built in integrations with Red Hat. I think like that's one of those other ones. But so the entire idea is that as you have the entire analogy of taking your application code and then creating the different layers that you have when you're, let's say, creating a Docker image and then eventually or you deploy it anywhere. Similarly, like using that similar kind of an architecture of having different layers that represent the different parts of your machine learning ecosystem, rather than having to rely on placing your different model artifacts in different locations and then having to deal with the complexity of managing all of them together. But the different teams that are present in your company, whether it's the data scientists or it's the DevOps engineers, you can just have it all in a centralized location and still use the same set of DevOps tools. Which I think the biggest factor why we are seeing a move towards having more emphasis on how OCR artifacts can be supported better for AI projects. And of course, there's the other aspect to this, which is the security. So I know like Gorkem kind of talked about how we can also sign these model kits, but at the same time, there are inbuilt features where you can also then scan them for vulnerabilities, which is
Yeah.
a more of an enterprise use case where uh, you cannot always ensure that your model might be accurate, because sometimes someone might have done some prompt injection to an LLM, or perhaps because a lot of times, especially if you're dealing with these LLMs and the teams do not have a much insight into what was the original training source of these materials, of this model, or if someone has on purpose tried to probably make or add poison to these models. Like model poisoning itself is another discussion altogether. So how we can scan and ensure that only authors that have originally actually written this model have actually published it. So all
Yeah.
those are also important aspects of modern day security.
Right. For instance, a good example is one of the things that you do with your Docker containers is you use something like OPA to uh, have policies of what kind of Docker images that can be deployed to your um, clusters, for instance, or not. And one of the ways to do that is you attach these attestations to your Docker containers when the OPA agent reads and says, "Oh, okay, this Docker image or this container image has more CVEs than the policy allows it to. Like there are high risk CVEs. So uh, I'm going to reject the deployment because the container image is not safe enough according to my policies. So when it comes to LLMs and models or AI ML models in general, there is no such mechanism today where you can reliably put an attestation and someone or something comes in and says, "Oh, okay, I'm going to read this attestation and decide whether that's within the boundaries of our deployment policies." So with with ModelKits, you can actually easily implement a secure supply chain using ModelKits. So and it's not actually very hard. Let me just share this little example here that I have, and we can even just go and do a demo of it as well. So when you are using a model kit, one of the things that you have access to is now you are able to access to the whole cloud native ecosystem of secure supply chains. And there are many tools in that area, but one of the things that I like a lot is Cosign. And this example basically tells you how to use Cosign to add an attestation to a model kit. And as you can see, there's nothing specific to a model kit here. It's basically your run-of-the-mill Cosign commands. You generate a key pair, you create an attestation. In this case, it's a very basic JSON file. And then you say cosign attest with the key, with the JSON to the model that you already have, the model kit that you already have. And then later on, you can verify it. So what this gives you is you can actually have whatever you have in this attestation.json. When you verify it, you can actually read that. But also you're verifying that this information here was added by whoever signed with the signature of the created key pair signature. So you are verifying that the attestation is valid, and also you can rely on that information to do something. You can imagine that instead of this basic attestation JSON, you can imagine that I can have CV scans, or not CV scans, but model scan results, or even validation results that are attached to a model kit. And from those results, you can have a policy which says, oh, okay, instead of deploying something that we are not very confident with, or doesn't have a very high score on our tests, we're gonna just reject the deployment at that point. Should we do a demo, or are there any questions that I'm missing?
I posted a bunch of
so I saw
questions
that
on the
Dharma
chat,
had-
but we can do the demo first. I think that will help clear out a bunch of things, and then maybe we can take the questions at the end.
Yeah. Okay. So we talked about, let me just move things in the correct windows. I guess you're able to see this. Are you able to see my screen?
Yep.
All right. So what I'll do is I have two folders, and if we look at these folders, it's basically the contents of a typical model kit, right? It's like there is a kit file, a license file, a README, and a Giga file, and some policy file, essentially. And this one is really the Llama 3.2 with the F16 instruct quantization. So what I'll do is I'll just, just to show how this works, I'll just show that, oh, here's what I want you to do. Model the package.model folder and give it a tag, and let's call it naming is hard. Demo. Apparently, I haven't updated my Kit CLI, which it reminds me. So this is basically what it does, right? The moment that it says, okay, I just saved this model in here and all that. And one of the things that you're going to notice is there are some messages here that says, oh, this was already saved, this was already saved, this was already saved, and this was already saved. The reason why it actually says that is because when you look at my list of models, this model was already in my local cache. So the Kit CLI is actually smart enough that if it notices that a file that you're trying to package is already available in the local cache, instead of creating another version of it and saving it, which is in this case would be 2 gigabytes, it just refers to it. So the local cache is very smart in the sense that it's not going to duplicate even a single doc file or a README MD, and it will keep all your blobs unique or singular with just references to each other. So that was the kit pack command, and that's the list command. Let's do a kit unpack. Oh, I didn't give it a tag properly. Or did I call it latest? No, I did not. So let's unpack this one then. Basically, it's the same thing. Why does it think that? Oh no. Okay. All right, so it basically did the unpacking here. And this is essentially the same project that you can use. But what you can do differently here is, let's do a kit dev start. And this is going to basically start running the Llama version, Llama file behind the scenes. Of course, you cannot see this, but believe me, it's a beautiful screen where you can. All right, let me just change the sharing. Let me just share this whole screen.
for some reason it's coming inverted.
Oh,
Is that just for me?
No, it's inverted. It looks like a
Oh, okay. I see
Mirror
what you're
image.
saying.
yeah.
Okay. Let me see. I think I
That's the
didn't.
first.
Um,
And unlike, so while Gorkem is probably just fixing that, I think one additional thing I just wanted to also kind of talk about is, so of course, what's next? You have published the model kit to a repository or to a registry. The next thing is that because it follows the same OCI, artifact uh, format, you can essentially think of it as a replacement for your standard containers and actually run it on top of platforms like Kubernetes. So, for example, on the Josu platform, you will have the capability to actually run a model kit as a init container and then run it on a Kubernetes pod and deploy it with the help of Kubernetes or any other such kind of supported environments where you can actually host a container, or you can
yeah.
run in a container.
Yeah. Okay. So let me just quickly go through that, and then we can talk about the possibilities that you have once you have something like a model kit available. So as I said, this is a sort of a development environment for us, so you can just use it the same way that you would use for any of these such platforms. I'm pretty sure you have seen it. It just runs it locally, and we do provide a little bit more tooling here so that you can, get started with this more quickly and see the responses that is coming out of the Llama runtime as well. So it's more of a UI that is tailored for the development use case rather than, it's not something that we do for the, yeah, so we're not really trying to be a local runtime, but you basically get the same sort of control over the settings, the messaging, and a little bit more development tools that you can play with. So the other thing that we can talk about is a little bit like as Shivay hinted a little bit, is once you have a model kit, you have access to all the information that you need for that project. So for instance, in our own registry in Josu Hub, what we do is we take these model kits and generate Docker images that you can directly uh, deploy to a Kubernetes cluster as part of the hub. And the reason why this is, I am very carefully calling it generate and not build a Docker image, is because that's exactly what Josu Hub does. Because all these layers, model kits, the layers are essentially layers that can be mounted to a Docker image. We basically rewrite a base image and add them layers from a model kit. Therefore, making the Docker image generation for inference purposes, but it can be for any purpose, much easier. Another thing that we do is anything that is pushed to Josu Hub, we actually run a model scan behind the scenes and attach an attestation And if you go to Jojo Hub, you can see a rendering of it, like if there are any security vulnerabilities of the model that you have pushed, it will be visible to you as well. But it's not only visible to you, but it's also an attestation that is attached to your model kit. So you can use that information elsewhere when you are doing a deployment to check for any vulnerabilities and stop the deployment, for instance. So the possibilities are various in that sense, that you can adjust the model kit to any pipeline that you can think of, and add more information to it as you move it through the stages of AI ML development. Did I miss any questions or?
Yeah, so I think Dharmit, sorry.
Yeah, I think you already answered a few of them, especially the scanning part. I was curious if Jozo is going to do some scanning, but you said it's already doing behind the scenes, and the attestation shows up on the Jozo UI.
Yeah, I don't know if it is appropriate to show the Jozo ML, but yeah, we do that for. Let me find the. For instance, let me just. I'm not sharing my screen, of course. So this is Jojo Hub, and this is an example model that I have pushed, and it's basically says it's an unsafe model. And if you go to the security report, you will see that there is like a ModelKit security scan done, and it's like there's a medium level issue on this one. And yeah, let me just log in so that we can see the.
And as I mentioned, like at the same time, you can also add it as part of your CLI, because like I have tried out with the model scan CLI, which can also scan your local model that you might have for any vulnerabilities, and it can directly tell you that in your CLI. So that's also another alternative.
Yeah, and it's essentially what it is doing, right? It's behind the scenes, it's running a job that uses a tool like Model Scan and adds these descriptions. I think the interesting bit here is this is actually an attestation to the model kit, so it's not something that lives in the Jozo Hub itself, but in the registry itself. So it's so that information you can move together with the model kit to your pipeline, and in your pipeline you can use that information. So I think that's the interesting bit in there.
And another question I have, since we are pretty close to the end of the talk, but Ahmedabad is a ops heavy town as far as my understanding goes. I saw one of the pages in the documentation that explained how KitOps can be useful for application developers, for DevOps. If you could quickly run us through how this could be useful for the ops people, that would be very helpful.
Yeah. So the reason why one of the principles of KitOps was we wanted to be able to separate the concerns. So for instance, today when you go to an AI ML team, there are multiple roles in there, and one of the roles is the data scientist, right? And you have the DevOps, and then you have the application engineers. The problem that you see a lot of the time today is we expect the data scientists to work like application developers. Therefore, we expect them to deliver Docker images. To be honest, every time a data scientist that is asked to do a Docker image, and a Docker image comes from a data scientist, like I'm always, I mean, I have my own experiences. That's not what they are, you know, focused on. And it's like they are going to come up with a Docker image that is the one that they could make work, right? That's the best way to describe it. It may be a perfect one. It may be full of things that shouldn't be there. But instead, in ModelKit, you have this isolation. You never tell them that, hey, you know what? I want you to package me a runtime Docker image with the correct VLLM version at the correct VLLM configuration, and minimal CVEs and no CVEs on it, and keep maintaining that Docker image forever. I mean, that's not going to happen. You're not going to get that from a data science team. That's not their job, essentially. And then you have the other part of it as well. It's like you go to the application developer and you're delivering something to the application developer for them to test locally or test on their development environments. And what you're giving them is a Jupyter notebook. Like, that's not what it is, right? It's like you have this experienced Java developer, Go developer, or something of that area, and you end up sending them a Jupyter notebook. That's not very productive for them. Again, with ModelKit, that separation is there as well. It's like you're now giving them a ModelKit, which resembles very much like the Helm or Docker flow that they are familiar with, and then they can do a Docker dev start or Kit dev start, so that run it locally and then test against it, because it gives them a REST API at that point. And then you go to the DevOps part of it. In the operations, they know the things that they get from the data science team is model weights, configurations. Those are the things that data scientists should configure and deliver. But then the correct VLLM image and the correct VLLM the Docker image setup, those are not the things that you should get from your data science teams. And those are the things that you should be able to get on the DevOps team, right? Because that's where your expertise is. You know how to do Docker images, you know how to do deployments, and you want to be able to write scripts that basically protects your production from, for instance, harmful AI models. So you want to be able to get that information on your ModelKit. So I think that's the main benefit to DevOps teams and application teams and data scientists, in the sense that it creates a separation of concerns that is actually just a natural flow of any kind of pipeline that you are implementing.
I have one question. Like lots of the new AI or MLOps tools are coming right now because of this. The AI is booming trend, and few of the tools have the hardware limitations. Like recently, like let's say Docker released a similar kind of Olama tool, Docker model runner, and they have some limitations that it will run only the Apple Silicon chips and similar kind of. So, is there any limitations or for hardware side for running KitOps or?
No, we don't. We use this. There's a like behind the scenes for our dev um, like that limitation would apply to only our dev command. And for our dev command, there is this wonderful Mozilla project called Llama file. We actually ship a version of the Llama file together with our dev command. And Llama file is done in a way that it is platform agnostic. So it does enable different GPU architectures on different operating systems. So we do support all of them. Um, there are other solutions out there that you can do as well, but we thought that Llama and Mozilla was a good partner on that.
And yeah, just to also, I know, sorry, I just wanted to probably just add to the point regarding that ops part, right? So I think if you also look at it from the perspective that given the fact that KitOps is compatible with most of the DevOps tools, it actually does help with streamlining your ops workflows. So, for example, you could get the automated CI/CD integration with a bunch of different CI/CD open source tools that are out there. And given the fact that now you can have your model kit be hosted in any OCI registry, so you get that centralized model registry for easier management of the model. And if you're especially if you're now maintaining different versions of the model kit as was demonstrated by Gorkem. So I think that reliance on being able to use those specific tools, and of course the entire idea of now packaging all the different components of your model workflow uh, increases basically ensures that we have reproducibility, and also we can maintain audit, which I think are still important aspects of your ops team. So I think because of the nature and how GitOps has been designed, it inherently ensures that on the ops side of things, it's very easy to integrate.
Yeah. One question. So the getting started guide is very good, and using it, I was actually able to upload. I was able to upload an image to my private repo in the Jojo tool. So my question is, how do I scan it? Because when I go to the security report, it does not show anything.
Yeah. Well, it's a background process, so it may just take time. The scanner is going to reach to that at some point. When it does, it will update the web page. So yeah, it's a background job that just runs at certain intervals, essentially. Yeah.
And I think another aspect of this is that before you also actually publish the model, I think as a general security practice, it's always good to also
Yeah.
scan it locally. You could just run a model scan CLI locally and see whether the model that you have, because like let's say for instance, you could do a kit import command to import a model from Hugging Face. Now, at that point in time, if I'm not mistaken, Gorkum, we're not necessarily doing model scanning while doing the kit import command, but you could
No.
just
Yeah.
run you could just run an automated scan before you package the model into a model kit and then publish it to any registry.
Yeah. 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 I mean, don't Jojo does it regardless, but it's always a good practice to shift left.
Yeah.
So yeah.
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 I was just getting that. Just like you have Git dev start, which runs Olama behind the scenes, you could probably have a Git scan, which uses model scan behind the scene and help the user with that, because model scan might not be so intuitive to somebody might not be so aware that they could run it.
Yeah, and the the problem with model scan is it detects a very specific packaging issue, like with the pickle packaging format, H5, Keras. Like there are a few packaging formats that are vulnerable to this. But then if you look at most of the LLM packaging, none of them uses these packaging formats. So they use TensorFlow, they use other methods for packaging. Therefore, for most of the models, you won't really get any benefit from model scan. But having said that, it's like if you happen to be using any of the model packaging formats like Keras and Pickle or anything like that, it is always a good idea to use the model scan. But also, certain packaging formats are not really vulnerable to this sort of attacks. The scary attacks on AI ML is the ones that you can't really scan for. So, like for instance, Shivay mentioned like poisoning attacks, prompt injections, and so on and so forth. Those things are really, really hard to detect, and therefore it's like model scan is good, but it doesn't tell you the whole story about your model. And that's one of the things that is very important as well, because if you think about it, like you're importing a model from Hugging Face, or your employees are using random models from Hugging Face. And how do you know that they are using the Llama 4 model from Meta, but not the Llama 4 model that has been modified by the Hacker of the Month, right? So now, how do you verify that, right? That's why it's very important to have a signing, for instance, to verify that, oh, I actually got this from this repository, this SHA, this is the file it was, so that you can always go back to it and say, you know what, this model was a poisoned model and we used that. Like, I'm pretty sure there are cases out there that people are using models that they don't know the origin from, and that may or may not have information that or prompts that is harmful to them. Like we are going to see about them in the future, right?
Yeah, it's like those early days of Docker Hub
people.
where people would push all the kinds of images, and you could also come across some nasty images if you were not verifying who you are pulling it from. Just pull an Nginx image, but yeah, it's not vetted by some organization, and you might very well be pulling in something that's dangerous. So this sounds exactly like that, but from Hugging Face, you could mistakenly pull it from there.
Yeah, exactly. And you have also data sets in Hugging Face as well, right? So it's very important. Like if you're taking a data set, random data set, and training your model with it, then your model starts to give answers that you're not expecting. Like Earth is flat. And so that's what happens.
Okay. Do we have any more questions for Gorkem or Shivay? We are already over the hour by 10 minutes. Okay, I take that as a no. Thank you so much, Shiva and Gorkem, for this talk. I don't know about the others, but for me, majority of the talk was packed with stuff I was not really aware of. Probably hadn't even come across. So this was an absolutely wonderful talk. Thanks a lot for taking out 60 and 10, 70 minutes out of your day and doing this talk with us.
Yeah, I think we need a follow-up session. This was very, very good. Thank you.
Thank you. Thank you for your time.
Absolutely. Yeah, we'll be in touch. And if there is anything like more specific, probably like a more deeper hands-on session, we can probably plan that. So please do let
Yep.
us know.
Yeah.
Yeah.
Definitely. Thank you for joining, Shivay, Gorkem.
Thanks for having us.
Bye.